It's math time with Mr. Mock. It's math time with Mr. Mock. It's math time. Hey, algebra. We are transitioning and continuing with our functions and looking at different ways to write arithmetic sequences. All right. So we're going to do recursive and explicit formulas today when we're looking at a different sequence, arithmetic sequence. All right. So a recursive formula. When you're writing a recursive formula, what you're doing is looking at a sequence and then you're connecting each term in the sequence to the term before it, right? So how do you go from one term to the next, to the next, to the next? And then you're writing a formula to show that. So a future term, and an nth term basically means any future term. So a sub n, so we say that as sub n because it's a subtext there, right? So a sub n equals a sub n minus 1. So that means the term right before this one, a sub n minus 1, plus d being the common difference. So how do I go from, what's the common difference from one term to the next, to the next, to the next, to the next? How am I going from one term to the next? Okay, so that would be the formula, the setup that we're going to look at here for recursive. Explicit, so we're going to use this as another way to write a way, like how to predict a future event based on the information we have so far. Okay, so again, we're talking about a future term, a sub n. So it could be a sub, what's the 200th term? What's the 8th term of the sequence? Okay, so when we're talking about a term of a sequence, we have, well, actually, I'll show you in the example down below when we're talking about a term, right? So a sub n, and n is the future term. A sub 1, that means the first term, all right? What is the very first number of our sequence? A sub 1. Then we have the n minus 1. So this is the number, the term number, okay? So let's say I want the 20th term. So it's a sub 20 equals a sub 1, so whatever the first term is, plus, and since this was a sub 20, this would be 20 minus 1, because that's the term, times the common difference. All right. So if you want, if you are taking down these notes as I'm going over them, then this one might be a good time to just kind of pause, collect yourself, rewind maybe. Go ahead and make sure you've got these notes written down. Don't just look at this and listen to it. You should also be writing these down if you have not written it down, or if you printed this by any chance, because I did put this up on Google Classroom. Maybe take a moment and just kind of read over it, really think about what I said, maybe rewatch this portion of the video, just to make sure that you're kind of understanding it and not just having to go in one ear and out the other. All right, so why don't you go ahead and take a pause now and either rewatch this, write down the notes, just really kind of like go through what recursive and explicit is. Go ahead and pause now. Okay, you're back. All right, so what we're going to do is I just have one example before you work on the problem that has been assigned, okay? So I've got an example here, and I have a sequence. And what we're going to do is write the recursive and explicit formula for the sequence. All right, so here's the sequence. It's -4, 5, 14, 23, 32, and then it keeps going forever and ever and ever and ever and ever. All right, now if we were to go ahead and put the term numbers on this, right? So if I were to just go ahead and put terms, okay, and just make a line here, this would be term 1, term 2, term 3, that's term 4, that's term 5, right? So now I want to write the formula, and then what if I said, what is the 35th term going to be? And then, so that'll be the challenge. What is the 35th term? Okay, so that could be the challenge for us. But first and foremost, we need to write the different forms, all right? So we have the recursive form. And the recursive form, if you remember, we can take a look back up here, right? We're doing a sub n equals a sub n minus 1 plus d. So I just basically, I need the common difference. So what is the common difference? And for the common difference, I'm just looking from here to here, from here to here. How do I go from one term to the next? What am I doing to the number? And take a moment, just kind of think about that. And if you, let's see, -4 to 5, is that just +9? Are we just adding 9 each time? That's what it looks like to me, right? So I know that the common difference is +9. So when I'm talking about the recursive formula is just simply that. A sub n equals a sub n minus 1 plus 9. That's it. Do I need to do anything with the no. But isn't that a little easy? Yes. Because all the recursive formula is doing is it's telling us how do I go from one term to the next. So for example, for the fourth term, if I want to do a sub 4, I'm going to do a sub 3, which is 14, plus 9, which equals 23. And it shows me what a sub 4 is, which I already know. A sub 4 is 23. Okay, so all it's saying is take the number in front of it and add 23. Now, will this help us do a sub 35? No, because I don't know what a sub 34 is. That doesn't help me at all. That's kind of a bummer. I wish it would, right? Well, that's why we use the explicit form, right? So the explicit form, this gives us a little bit more structure in order to find those future events, which goes back to used to calculate future events terms. This one's a little bit stronger for us to use, right? So when we look at it, right, we're doing a sub n equals, and now I want to do a sub 1. So what is the first term? The first term is -4. And then I'm adding n. So that's the term, minus 1 times d, and that's the common difference. The common difference, again, was 9. So that is explicit form, but guess what? We can simplify that. We can simplify that. So let's go ahead and simplify it, right? So that's going to be -4, and then this would be distributive property. So it'd be plus 9n minus 9, right? That's distributive property. Combined like terms, we would get a sub n equals 9n minus 13. And look at that. That's a linear equation. We just wrote a function. Now, here's my question. Can I use this to go ahead and calculate the 35th term? Well, if n represents the term number, I can now do a sub 35 equals, well, that's going to be 9 times 35 minus 13. So this form helps us see those future events. We can go ahead and calculate them a little bit better. So 9 times 35 is 315 minus 13. We know that a sub 35, or the 35th term, is going to be 302. Okay? Now, that would be how you write the recursive and the explicit. I hope you've taken down those notes. I want you to really think about it. If you need to rewind and really think through what it was that we did, that works for me. Okay, so this right here was the recursive formula. Oops, I went through the n sub n minus 1. And then this right here would be the final explicit formula. Okay, go ahead and now work on that problem that I've assigned for you to do. And I will get to taking a look at those as soon as possible. All right, team. I'll see you later. This has been my math talk. Thanks for watching.